Now, and welcome back, and it's the higher plus 5 a day, and it's the 27th of Jan, and let's go with the first question. Right, 1.24 dot as a mixed number, use algebraic approach. Okay, so the question is very clear about what it wants me to do. It wants me to write my answer as 1 and a mixed number, in other words, something like this. So the way I'm going to do it is I'm basically going to ignore the 1 and then add the 1 at the end. Now, it's a bit risky because I might forget to put the 1 on, but for the sake of doing this video, it makes things a bit easier. So think about the fraction part. I've got x equals 2.4 recurring. If I multiply that by 10, I have 2.4 and then 4 recurring again. So although that's 4 and 4, the point is my recurring bits now cancel out. So if I take these away, 10x minus x is 9x. 2.4 minus 0.2 is 2.2, and the 4 recurring bits cancel out, which means that x is going to be 2.2 over 9, which is the same as 22 over 90 multiplied by 10. Let's simplify that down. If I simplify it down, it's 11 over 45. And let's remember to do the thing that I might forget how to do, but the 1 on the start. So that's going to be 1 and 11/45. Question done. Next question. Write in the form of a root 2. Okay, now what's interesting here is the question has helped you massively by telling you everything's going to be in terms of root 2. So if we think about root 72, that's the same as root 36 times root 2. Questions help me out here. So that's going to be 6 root 2. This one is the same as root 3 times root 6 is root 18. And root 18 is root 9 root 2. Again, the question helping me out, which is the same as 3 root 2. And then what am I doing? I'm sorry, knocked it over. I'm adding these things up. So 6 root 2 plus 3 root 2 is going to be 9 root 2. Not as bad as it looked, is it? Okay, question. Next question. Calculate an estimate of the interquartile range. Okay, wow, this doesn't look very friendly at all. Okay, I'm going to zoom in because it will just allow me to write the numbers slightly clearer. Now, you may see me do this elsewhere. So this starts at 0 and goes up to 64. Then the next one starts at 64, adds 74, and goes up to, what's that, 138. Then I add 155, God, which is going to be 293. Then I add another 80. I could very easily make, this could very easily go wrong, but 373. Then I add 26. Okay, that was a bit easier, which is going to be, okay, good. Tell you why I said good in a minute. Then I add 1, which is 400. Right, the fact I've got a nice round number here makes me feel comfortable I've added up correctly, or at least made 2 different errors which are cancelled out. Then what does it want? So it wants an estimate of the interquartile range. Now the interquartile range, if there are 400 items, is going to be the 100th item, a quarter, and the 300th item. And the 100th item is going to lie between 64 and 138. In other words, it's going to be in here. And the 300th item is going to be between 293 and 373. So it's going to lie in there. Now, if you haven't seen this done before, this is going to look complicated, but slow it down, watch it a couple of times, check you're okay with what I'm doing. Let's do the lower quartile. So I want the 100th item. I'm going to start at 64, so I need to move along 100 minus 64, 36 places. There are a total of 74 items in there, and they range from 50 to 45, which is a difference of 5, and then I need to add on the 45 I'm starting with. Let's do the 300 one. So 300 minus a 293 at the start of the range, divide by the number of items in the range, and then multiply that by the length of the range, which is 5, and then add on the start of the range, which is 55, and that's my calculation. Let's get my calculator out. So my calculator tells me that this is, reading from the calculator, 47.4. I'm going to do 1 decimal place because I don't need many decimal places here. And the other one is 55.4. That makes this calculation easy, which means the interquartile range is the difference between lower quartile and upper quartile. Take these 2 numbers away and I get 8.0. And what are we measuring? We're measuring kilograms, so 8.0 kilograms. Tough question, very difficult. And actually, we do that again in A level, but it's quite difficult at GCSE. Next question, and I think final question today. Shown is a graph of the function y equals f of x. There it is. Sketch. Now, it's also good to know what these things are, because then I know what I'm looking for. So this is a reflection in the, well, plus becomes minus, so it's in the x-axis. And this one is a translation of minus p 0, where p is between 0 and 1. In other words, the right-hand side won't cross over the y-axis. So let's do these separately. So the first one basically turns upside down, but keeps the x values the same. So let's try and get this graph properly. So in other words, this stays at 1. This stays at minus 3. As long as you've got the numbers correct, don't worry too much about it not being super accurately drawn. And this goes, it's still minus 1, but it is now plus 4. First question done. Next one. Now I've got to be careful here. I'm moving it left by p, but p is less than 1. So I'm going to stay this side of, I could pretty much draw the same shape. However, what I'm doing is I'm changing this to 1 minus p, and this one here is going to be minus 3 minus p, because I'm moving it left by p. And this here is going to be minus 1 minus p, but my y value stays the same, so that's minus 4. That's a tricky question, isn't it? Nice, difficult question to end today on. It's been quite a lot of maths going on today. We've done some IQR, done some surds, some transformations. Good mix, as ever. Well done if you got those, and I'll see you for the next one. Do subscribe to the channel, really helps it just get to other people, helps this grow a little bit, and I'll be very thankful. Thanks all, bye.